Hello friends, welcome to my channel. In today's session we are going to see Ho-Ramamoorthy two-phase algorithm. We know that in distributed environment multiple systems work together. So when these systems work together they share each other resources. Ho-Ramamoorthy two-phase algorithm is a centralized deadlock detection algorithm which is used in the distributed systems. We know that there can be multiple sites in the distributed environment. So these sites perform their task with the help of each other. Consider that there are 3 sites. So probably every site may hold multiple processes. So site 1 may contain 3 processes, site 2 may contain 2 processes, site 3 may contain 10 processes also. And they are having their own resources which might be shared in the distributed environment among different sites. So there will be a designated control site that will gather information from all the other sites to build wait for graph, which is also known as WFG. So normally WFG is a graph in which the relationship between processes and the resources is shown. With the help of WFG, it is easier to find out the deadlocks in the system. So deadlocks are discovered with the help of these WFGs or wait for graph. Let's go ahead. Ho-Ramamoorthy two-phase algorithm contains two different phases. In first phase, the designated control site will collect the information from all the sites, and in second phase, the information which is collected by the designated control site will be analyzed by that site, and then wait for graphs are formed which may help us to check whether there are deadlocks in the system. So let's go into the detail and let's try to understand what exactly happens in two-phase algorithm. Consider this diagram. We have 3 sites in this diagram. Site number 1, site number 2 and site number 3. Site number 1 is holding process P1, site number 2 is holding process P2 and site number 3 is holding two processes P3 as well as process P4. Now in this case, if we say that process P1 is waiting for resource R2, process P1 is holding resource R1. Now process P2 is holding resource R2. Until process P2 releases the resource R2, the resource will not be allotted to P1. Similarly, process P2 is also holding R3 resource, but process P2 is waiting for resource R4. So dependencies between the processes and resources is given. So now in this complex environment, Ho-Ramamoorthy two-phase algorithm works stepwise. In first phase, control site does request to every other site which is getting executed into the distributed environment. So these are the request message which are sent by the control site. Once the request will be sent by the control site, reply will be received to the control site and which will contain the exact information about the status of resources and process which are getting executed on that site. So site 1 will give reply in this term. Suppose site 1 tells P1 is the process which requires R2 resource and P1 is the process which is holding R1 resource. Site 2 will reply that P2 is holding R2 resource, P2 is also holding R3 resource and P2 is waiting for resource R4. Site 3 will tell that P4 is holding R4 resource, P4 is waiting for R5 resource. This R5 resource is held by process P3, but process P3 is requesting for R1 resource. So process P3 is requesting for or waiting for R1 resource. So if we see the diagram properly, then so control site when gathers this data, it analyzes that data and it tries to, after analysis, control site in this case will find out that there is a deadlock because a complete loop is formed in that case. So control site will detect a deadlock in this particular case. So that is what the role of control site. So Ho-Ramamoorthy phase 2 algorithm works in two phases. In first phase, Ho-Ramamoorthy algorithm collects the information from all the sites which are running into the distributed environment, and then after getting the exact information, it constructs the wait for graph, and on the basis of this wait for graph, it finds out whether the system contains deadlock or not. After formulation of the WFG or wait for graph, the control site never come to the conclusion that there is a deadlock inside the distributed environment. Once again, the control site reconfirms the deadlock. It again requests to the local sites about their status information. Based on that, again it reformulates the wait for graph. And in the wait for graph, if there is a cycle, then by considering both the cycles in earlier phase and in the second phase, the control side confirms there is a deadlock inside the distributed environment. So let us summarize. In Ho-Ramamoorthy phase 2 algorithm, first of all, control side sends request messages to the local side and it collects the status information from the local sites. On the basis of the information received from the local side, control side constructs the wait for graph. If there is a cycle present inside the wait for graph, again for reconfirmation of that cycle, control side again takes the status information in phase 2 from the remaining sites or local sites. Now again it constructs the wait for graph. If cycle is confirmed in both the cases, in first phase and in second phase, then control side declares about the confirmation of the deadlock in the distributed environment. So at the end, we will summarize few points. We can say that there are some advantages and disadvantages associated with Ho-Ramamoorthy phase 2 algorithm. In advantages, we can say that this algorithm is simple and easy to implement. And second advantage can be this algorithm is efficient for small systems where number of processes and resources will be less and there will be less overhead of collecting and analyzing the information. So in small environment, this algorithm will work. The disadvantage can be centralized bottleneck. The control side becomes a single point of failure, and another disadvantage we can say that potential for inconsistency when the system state changes rapidly between when the information is collected and when the information is analyzed. So these are some advantages and disadvantages of Ho-Ramamoorthy algorithm. Hope that you might have liked this video, so please share it with your friend. Please like the video and subscribe to my channel. Thank you.